Hello everyone, this is our last video about gases, and this is kind of an extension of using the ideal gas law to solve for a couple of different things. There's one more sort of property of gases that we can use involving partial pressure. So let me tell you what we know about partial pressure. Partial pressure just says when you have a mixture of different gases the total pressure is equal to the sum of the individual pressures. So there's actually kind of an equation we can write for this. Our total pressure is equal to our first pressure plus our second pressure plus our third pressure, third pressure plus however many other pressures we have. We can just add them all up. So a really easy example of this is this problem. It says a mixture of gases contains 3 atm of H2, 5.6 atm of O2, and 10 atm of N2. What's the total pressure? So here we would just add these. 3 plus 5.6 plus 10 is going to be equal to 18.6 atm. And that's really nice and easy. Here is an example where we're going to combine this with the ideal gas law. So this says, what is the total pressure in a 250 liter container that contains 3 grams of O2 gas and 5 grams of CO2 gas at a temperature of 300 Kelvin? So we can set up this problem. We're going to need to use the ideal gas law, which again is PV equals nRT. Let's just write down our variables. And we'll leave a lot of space for N for reasons that you'll see in a second. Our pressure is what they're trying to have us find. So that's X. Our volume is 250 liters. Now our N is moles, and we've actually got 2 gases here. So we've got O2 gas and CO2 gas, and we've got grams of each. So what we actually need to do is convert each of these into moles. So we take our 3 grams of O2, convert that to moles, our 5 grams of CO2, convert that to moles, add those 2 moles together, and then that's our total N. So the molar mass of O2, that's 2 oxygens, so that would be 32 grams per 1 mole. The molar mass of CO2 is 44.01 grams per 1 mole. So if we solve that really quick, 3 divided by 32 is going to be 0.09375 moles, and 5 divided by 44.01 is going to be 0.1136 1 moles. So if we add those together, we're going to get about 0.207 moles. Okay, so that was kind of a lot of work, but that's our N. And then our R is going to be 0.0821, and our T is going to be 300 Kelvin. So basically, I just used the property of partial pressure to realize that if I've got 2 different gases, as long as I find the moles of each gas, I can just add those together, and now I can just plug this into my equation as I normally would. So I've got my pressure as X, my volume is 250, my N is 0.207, my R is 0.0821, and my T is 300. So I just need to simplify that right side, and that ends up being X times 250 equals 5.098 divided by 250, and we're going to have a pretty small pressure here. It's going to be about 0.02 ATM, which makes sense. This isn't very much of either of these gases, and we've got a huge container, So it is going to be a very low pressure. And that is how we use partial pressure and the ideal gas law together. Just if you get 2 grams of 2 different gases, find the moles, add the moles together.